All right. So here we go. Um, okay, question number 11. If aqueous solutions of magnesium acetate and lithium hydroxide are mixed, what insoluble precipitate is formed? All right, so let's start writing an equation. Mg C2H3O2 2 plus, that's aqueous, plus LiOH, that's aqueous, gonna react to give me what? Well, this is gonna be a double replacement reaction. So we're gonna have MgOH2. We'll leave the state of that open right now. And LiC2H3O2, lithium acetate, and we'll leave the state of that open. Well, we don't really need to do this, but let's balance it. Cool. Done. All right. So anything with a group 1 metal is going to be aqueous. So that pretty much answers the question right there. Because this is an aqueous solution, so this will be the solid. That'll be the precipitate. So your answer is MgOH2 or magnesium hydroxide. Cool. All right, let's move on to the next one. What is the net ionic equation for the reaction that occurs when aqueous solutions of lead-2 nitrate and ammonium chloride are mixed? All right, let's start by writing a normal reaction. So when you mix lead with a halogen, it is going to form a solid precipitate. So that's going to be a solid. So if you remember when you're writing your net ionic equation or your total ionic equation, you don't break apart solids. So that's going to stay. So we're going to go ahead and write a total ionic equation first, and then we'll cross off what we don't need. So total ionic equation, we have Pb2 plus aqueous plus NaO2 NO3 minus aqueous plus 2NH4 plus aqueous plus 2Cl minus aqueous to give us 2NH4 plus aqueous plus 2NO3 minus aqueous plus Pb, that was supposed to be a B, PbCl2 solid. All right, let's start canceling. So lead and lead, so that's fine. Nitrate, nitrate, ammonium, ammonium. So now that we've taken the time to reduce that down, we have Pb2 plus aqueous plus 2Cl minus aqueous to give us PbCl2 solid. So a little trick, when I'm doing these, what I will do is look and see what product is going to be a solid product. So I'll write this first, and then when I go back to instead of writing this out every time and crossing it out, unless I really just don't know, um, I'll look and see, okay, what's my solid product? Okay, this is my solid. So over here, as long as this is balanced, I'm just going to need what it takes to make this. So I would just need this and this and this in my net ionic equation. Instead of writing everything out and then canceling, you can just go, oh, okay, so I need that plus that to give me that, which is what I did, but I wrote everything out for you guys so you guys can see the entire equation. Okay, let's move on to the next one. Okay, what's the oxidation number of chromium in Cr2O7? So what I like to do in these is set up a little algebra, super simple algebra, once I know something that isn't going to change. So 2 minus, that's what oxygen is always going to be unless it's a peroxide, but then it's technically not oxygen, it's peroxide. So what I'll do is 2 times Cr plus 7 times negative 2 is going to equal negative 2, right? Because we need it to equal the charge. So if we were talking about NO3 minus, it's going to be N plus 3 times O equals negative 1. Okay, so then we'll just do some algebra. So we have 2Cr minus 14 equals negative 2. Add 14 to both sides. Then we get 2Cr equals 12. Divided by 2. Cr equals positive 6. There is your answer. All right. So these are the ones that tend to throw people off because whatever is being oxidized is your reducing agent. Whatever is being reduced is your oxidizing agent. So it's the opposite of what's happening to it is what agent it is. So let's go through really quick and assign oxidation states to all of these molecules, or not molecules, I guess atoms. I know I did this on this paper right here. Cool. So anything in its normal state, its elemental state is going to have a 0. So these two are going to have 0. We know oxygen is going to have negative 2. And we know sulfate, SO4 2 minus. So sulfur plus 4 times negative 2 equals negative 2. Sulfur is going to have a positive 6. So plus 6. And it's going to have the same thing over here, minus 2. Aluminum is going to have a 3 plus. You can do the math really quickly, check it out. It would be 2Al plus, well, in this case, 3 times negative 2, right? Because this whole thing overall should be a negative 2. And that's going to equal 0. When you work everything out, positive 6 divided by, yeah, so plus 3. Cool. And then hydrogen is always going to be plus 1 unless it's a hydride. Then technically, like I said, it's not a hydrogen. So aluminum is, so remember oil rig, oxidation is loss, reduction is gain. It's going to from 0 to positive 3. So 0 to 3 plus. And then if we look, hydrogen is going from plus 1 to 0. So hydrogen is being reduced, which means it's the oxidizing agent. But not hydrogen itself. It's everything that it's attached to. So H2SO4 would be your oxidizing agent. When you're talking about aluminum, aluminum is being oxidized. Which means that aluminum is your reducing agent. If you look to aluminum's by itself here, so it would just be aluminum is your reducing agent and H2SO4 is your oxidizing agent. Okay, let me know if that like confuses you or anything like that. I want to make sure that I can help you guys there. Okay, cool. Okay, so we have a 4.691 gram sample of magnesium chloride dissolved in enough water to give 750 milliliters of solution. So that is 0.750 liters. What is the magnesium ion concentration for this solution? Okay, first thing we need to do is get the molarity, and then from there we'll break down the moles of MgCl2 into moles of Mg, which are going to be equivalent. Because for every 1 mole of MgCl2, magnesium chloride that you have 1 mole of Mg2 plus of magnesium ion. So, but I'll write out the whole math. Okay. We don't want a 128 point brush. That would be huge. Okay. So 4.691 grams of MgCl2. This is being dissolved in 0.750 liters times 1 mole of MgCl2 is whatever grams of MgCl2, and then 1 mole of MgCl2 is 1 mole of Mg2 plus. So that should give us blank molar Mg2 plus. The molar mass for MgCl2, at least that I got, is 25.211. And then let's check units. Grams of MgCl2, moles of MgCl2. We're left with moles of Mg2 plus per liter. And our mass, which is molarity, moles per liter, gives us 0.0657. Cool. So that's that video. I hope that helped you guys out. I think I have one more after this. Yes, the last questions. All right. See you in the next one.